All right, so we were talking about quadratic equations. We started talking about how to solve them in various ways. Here's another way to do it. It says using square roots. This is going to lead into something probably later in the week called completing the square, which is another way of doing these things. So, but let's kind of get the vibe for what's going on here. We went over this last time, but we'll go over it real quick because, like I said, I'm sure we've forgotten about it since last Thursday. All right, so it says solve each equation by inspection. So the real takeaway from this is when you take the square root of a number, you're going to get a positive version and you're going to get a negative version. So what we're doing here is we've got x squared equals a number. We want to know what x is, of course. So then we have to take the square root of both sides. So then x is going to equal plus or minus the square root of 56. So you technically get two answers. All right. So if we forgot what the square root of 256 is, most people don't know that, and rightfully so. Where is my calculator? Get back into the picture here. Just a second. All right, here we go. Drop him down a little bit. All right. Always good to have our handy-dandy calculator on hand here. So then we say 256, take the square root, and then a 16. So our answer is plus or minus 16. That's really all there is to it. So the same thing here. And the square root of 144, so x is going to be plus or minus. This is probably the biggest square root most of us know. 144 on the old times table is 12 times 12. So that's going to be plus or minus 12. Okay. So we do the same thing here. But now we're taking the square root of a negative number. Can we do that? Can we do the square root of negative 20? Well, let's try it. So we do our calculator. We say 20 negative, and then we try to take the square root. Invalid input. That basically means we can't do it. Yeah, good, Chloe. And there's no solution. Perfect. So this guy, no solution. So if you see x squared equals a negative number, we're going with no solution. So notice the next guy here is negative 27, so no solution for him as well. Okay. Okay, so next guy, same thing. Do the square root and square root. So x equals plus or minus the square root of 91. Now this is usually where our guys will try to reduce this square root, bring a perfect square out front. But I'm not seeing any perfect squares at work here. Certainly can't divide it by 4. Won't divide by 9. Close, but not quite. Right? 16? 25? Nah. 36? 49? Nope. And we're already halfway past, so that means it. What you could do also is you can do a prime factorization on this. As it turns out, we can divide this guy by 7. Not that 7 is a perfect square, though. So we do 91 divided by 7 is 13. So this guy turns into 7 times 13, but neither of those are perfect squares. So we can just leave our answer like this. So we do a quick check on that. Okay, so the same thing here. We do the square root. Now, 0.25, let's think like a $0.25, a quarter. Quarter is 1/4. So this is really x equals the square root of 1/4. Now we could rewrite that as the square root of the top and the square root of the bottom. That's fine. So sometimes this makes it easier for people. We go the square root of 1 over the square root of 4. Square root of 1 is just 1. Square root of 4 is 2. So our answer is plus or minus 1/4. And again, if you don't want to do that, we can still use our calculator. So we come up here and we say, all right, we're going to do 0.5, take the square root. Nope, that's the wrong one. I messed something up there. Hang on. 0.25, there we go. And then take the square root, and we get 0.5. And 0.5 is 1/2. Okay? So that's what we did last time at the end of class. Went through that really quickly. All right, so let's go ahead and check out some other problems here. All right, so a little fancier, right? So this one says solve each equation. We've got 12x squared equals 300. Okay, so with this one, let's think about algebra that we've done before. If this was 12x, just an x, equals 300, what would you do to solve? What would be the first thing you do if you had 12x, if this thing were right, equals 300? Divide, yeah, you divide by the number in front of the x, right? You do the same thing here. It's all good. Okay, so we do that. These guys are going to cancel out, so we're going to get x squared equals, let's break out our calculator for this one. So we'll clear it. We go 300 divided by 12 is 25. So x squared equals 25. That turns out to be a good number, right? Because that's a perfect square. So we take the square root of both sides, so we get x equals 5. But remember, it's a plus version and a minus version, because -5 times -5 will also give you positive 25. So that's our guy. Okay, so next one. He looks a little suspect because of that negative sign, right? So we'd like to switch the sign on him, so we switch the signs, right? But -0 is still 0. So really this is just x squared equals 0. You have to take the square root of both sides. We get x equals, can you take the square root of 0? Is that cool? No? Well, let's try it. So clear it out. We have 0. We take the square root of that. It still equals 0, right? So 0 times 0 is 0, so that's okay. So we actually can do that. Now, there is no such thing as +0 and -0. So in this case, this is a very rare thing where we have just one answer, and that answer is 0. Okay? Can't take the square root of a negative number, but 0 is not negative. It's not positive either, I know, but so that's cool. That one's okay. So just a little something to keep in mind. Questions? Good so far? All right. Okay, so this guy. So we have 0.1 x squared equals 100. Okay. So we're going to do standard operating procedure. We're going to say I'm going to divide by 0.1. And we do this side over here. So we do 0.1. All right, so now here's the thing. When you divide by a number smaller than 1, you get a number bigger than you started with. So let's check that out. So we say, okay, we got 100, and we're going to divide him by 0.1, and we get 1,000. Interesting. All right, so then we have, this guy's cancel out, right? So I've got x squared equals 1,000. All right, so then we want to do our standard thing here. We want to take the square root of both these guys. So x is going to equal plus or minus the square root of 1,000. All right, so this is definitely one that we can reduce. Let's go back to where we were. There we go. All right. So we know 10 times 10 is 100. That's a perfect square, right? So I could rewrite this as x equals plus or minus the square root of 100 times the square root of 10, right? Square root of 100 is just 10. So we'll have a regular 10, we'll have a square root of 10, a plus version, a minus version, and we're done. Questions? So again, this is all standard procedure. You got a number in front of your x squared, you divide by it. Then we take the square roots, and then if we can, we go ahead and quote unquote reduce the square root and get as much stuff out from underneath it as we can, which is what we did. So it's all good. All right, next guy. So standard procedure says we're going to divide by this guy, right? Divide by the number in front of the x squared. All right, calculator. Move it over. So we've got 18, there we go, 16, divided by, I didn't want that, you go back, there we go, over, okay. Divided by 227. So it's 8. So we get x squared equals 8. All right, standard procedure says we need to take the square root of both sides. So let's do that. So we get x equals plus or minus the square root of 8. Okay. Now, even though that's kind of a small number, remember the first perfect square is 4 that we can use. I mean, 1 times 1 is a perfect square, but that doesn't really help us. So 2 times 2 is 4, so we could rewrite this as x equals plus or minus the square root of 4 times the square root of 2. Because 4 times 2 is 8. Boom. But then, the reason we do that is the square root of 4, we could just make a regular 2. So it becomes 2 times the square root of 2. And if you want to check it out to make sure you're okay, you can use your calculator again. So in this case, we've got 8 there. Let's square root it. 2.828. Okay. So does that equal 2 square root of 2? Well, let's find out. So we go 2 square rooted, and then times 2. Check it out, same number. So again, we got the 0.2828. This was our previous calculation right here, and here's our new calculation. So they're the same, so we did it right. Good way to check. Okay. Or you could get a TI-XS30, no, TI-30XS, there it is. And you type in the square root of 8 and hit enter, and it goes, oh yeah, 2 square root of 2, here you go. It does it for you. Nice. Moving on. Questions? All right, let's check out a few more. All right, so we see x squared equals negative 36, but we do have a negative on this side, don't we? So that's going to be okay. So we divide by negative 36. Over here, we're going to divide by minus 36. So these guys cancel, and this just becomes 1. So we get x squared equals 1. Square root it, right? So x equals the square root of 1, which could be plus 1, but could also be minus 1. So again, most quadratics will give you 2 answers. There are exceptions, but generally that's what's going to happen. Okay, so let's check out the next guy. Before we get going, do we think we have a solution here? Think we're going to get an answer for this one? What do you think? You think we might get an answer here? Do you think we'll actually get an answer for this one, or do you think it's going to be no solution? And why am I thinking that so early? So again, if you're not sure, yeah, that minus sign, right? Kind of suspect. But if you're not sure, we could still do standard procedure, right? We'll do minus 16 here and minus 16 here. So Chloe's getting the no solution box. So these guys cancel. I get x squared equals, oops, that was weird. So x squared equals 200 divided by 16 negative. That's negative 12.5. So first of all, it's not a perfect square, and second of all, it's negative. So automatically, when we see a negative, x squared can't give you a negative answer by itself. So you can't have a negative around the square root, right? So as Chloe predicted, no solution. All right. So yeah, anytime you're doing these, if you're going along and all of a sudden you've got a negative under a square root, that's not happening, at least not yet. There'll be versions of that for later, but not now. All right, let's continue on. Maybe try another color here just for fun. So this one says x squared plus 65 equals 90. Okay. What do we do here? So before we had numbers in front of the x squareds and we were dividing. Now we've got just an extra number tacked on. So what are we going to do? What do we got to do with this guy? Because again, if we're solving for x, we need to get everybody that is an x to the other side, right? So how do we move that 65 to the other side? And again, this is pretty standard algebra stuff. Yeah. So we're going to go ahead and say, okay, we're going to take 65 from here and 65 from here. Sweet. All right, so we got x squared. These guys go away. That's why we did it, right? And then we've got 90. So we got 90. Let's clear this out. Minus 65. Oh, there's our good friend 25 again. So we already know how this story is going to end. We take the square root of both sides, and x is going to be 5, but we can have the plus version and the minus version. So again, 2 answers. All right, so the next case is almost the same, right? Except in this case, we're going to add 65 to both sides. Okay? So then I'm going to get x squared equals, I'll go old school here, so that's going to be 5. That's going to be 15. So 155. So we take the square root, we plus or minus. So the question is, can we reduce that square root? Okay, well, let's find out. So let's do a little side project here. We will take 155. So it ends in 5. That means we can divide by 5, right? So let's do that. See if this helps us at all. All right, so we've got 155 divided by 5. Gives me 31. I think 31 is a prime number. I don't think we can divide him by anybody. So that's just going to be our answer then. So this will be x equals plus or minus the square root of 155, which would probably be 12 point something, I think. So if, yeah, you want to get a little better vibe for it, you can always do that too. You can say, okay, so I know it's that, and this is the answer that the math guys are looking for. But if you want something a little more useful, shall we say, We do 155, and then we square root it. So yeah, 12.44, well, 12.45 really. So that's what I figured. And the reason I figured that is 12 times 12 is 144, right? But this is 155, so it's a little bigger. So then, okay, something a little bigger than 12. And it turns out that that's what it was, 12.45. So it's often very helpful with these guys if you can kind of look at it and kind of know what your answer should be before you get started. Questions on those two? Still good? Cool. All right, let's try a couple more. Oh, now we're getting fancy. Check this one out. But it really isn't. If you get rid of the x squared and just make it x, if we had 3x plus 8 equals 56, standard operating procedure here, right? Let's start with the 8. What do we do with him? So we need to get the 8 to the other side. So what do we do? Yeah, standard stuff, right? So we go -8 and -8. Cool. These guys go away, so now I've got 3x squared equals 56 minus 8 is what, 48? Cool. All right, so then standard procedure says, well, let's divide by the 3. Get rid of the guy in front of the x squared, right? Okay. So we'll have x squared is going to equal 48 divided by 3. So let's check that guy out. So we say 48 divided by 3 gives me 16. Oh, cool. That's a good number. Because again, 16 is a perfect square. So when we square root these guys, then we're going to do x equals, square root of 16 is 4, but always remember you get the plus version and the minus version, and we're good to go. Yep. Awesome. So this is an awful lot like the last set of problems where one was plus and one was minus. So we kind of got the same vibe going on here, right? So this time, instead of adding, or instead of subtracting the 8, we're going to add the 8, right? So we're going to add 8 here. And we're going to add 8 here. Okay? So if we do that, then this guy goes away. This is going to give us 4 with 1 over 64. So I've got 3x squared equals 64. Okay. So then standard procedure says let's divide by the 3. Cool. These guys go away, so I get x squared equals 64 over 3. So we're going to square root. We're going to square root. Remember, it's a plus or minus version of this. All right, so it turns out you can do some interesting things with this one because, again, you could write it as x equals plus or minus the square root of 64 over the square root of 3. Okay? So then what we can do is we can say, all right, well, the square root of 64, as it turns out, is actually 8, right? And then the bottom, we can't take the square root of. So we got the square root of 8 over 3. Now, here's a little side note. For some reason, I don't know why, hundreds, maybe even thousands of years ago, the math guys decided they didn't like square roots in the bottom of fractions and voted them off the island. Yeah, I don't get it either. So they don't like the square root on the bottom. So like, nope, 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 can't give that for an answer. So really? Fine. Here's how you get rid of that. We multiply by a fancy version of 1. And that fancy version of 1 is just going to be the square root of 3 over the square root of 3. So when you multiply together, we get 8 times the square root of 3. And the square root of 3 and the square root of 3 is the square root of 9. But the square root of 9 is just 3, right? So you could write it like this. And then again, plus or minus. So that one's pretty funky. That's what they call rationalizing the denominator, which is just a fancy term for saying we don't like square roots on the bottom. Okay. So that one's a little funky. That's probably above what we need to know at this point. But they threw it in there just for laughs. Any questions? All right, so let's do one more set, and I gotta take care of something real quick. So we'll do one more set, and then we'll call it. Okay, this looks scary. Not that big a deal. So again, nobody likes fractions, right? So in order to get rid of this fraction, what we want to do is we multiply this entire thing by 2. So what happens there is these 2's cancel out, and I get 4x squared plus 10 equals, but then you have to multiply the 5 by 2, so that equals 10. All right, that's a beautiful thing, because when that happens, notice we have 10 and 10 on both sides, right? Anytime you have the same thing on both sides, we can go ahead and cross them off. When we cross off over here, though, we have to continue calling it a 0, though. But that makes it really easy, because we have 4x squared equals 0. You divide 0 by 4, it's still 0. X squared equals 0, square rooted, and as we already established, you could take the square root of 0 and just get 0. Fabulous. All right, so the next guy's the same thing. This time we're going to multiply everybody by 4. So the 4's on the top and the bottom cancel, because we don't like dealing with fractions, right? So I get x squared minus 40. And on the other side, I've got 470 times 4, and I don't know what that is. So let's find out. So we go 470 times 4. Whoops, that was one too many times. Hang on. Let's try it again. 470 times 4. I did 472. Really? One more time. 470 times 4. Finally, 1880. Feels like the year I was born some days. All right. So then our next step is we go ahead and add our 40 to both sides, right? Standard stuff. Okay, so these guys go away. Now I have 8x squared equals, I'm going to go old school here. So we got 0, 2 with 1 over, so 1920. All right. Then we divide both sides by 8. All right. I'm not going old school here. I'm using the calculator. So I do 1920. I said 20. There we go. Divided by 8 is 240. So x squared equals 240, square rooted, right? Okay. And then we get x squared equals plus or minus the square root of 240. So this is one we can work with a little bit, right? So let's see some numbers we can divide this up by and see if we can find a perfect square that might go in there. All right, so let's do that. Let's go ahead and switch colors so we can differentiate what's going on here. So we've got 240. What's the number I can divide 240 by? There's two obvious choices. It ends in 0, or it's an even number. Take your pick. I don't know if 14 goes. Let's check it out. So 240 divided by 14. Nope, that one doesn't work. What's another possibility? 16? Let's check it out. That would be good because 16 is a perfect square, isn't it? So if we do 240 divided by 16, outstanding. 16 times 15. So then this would become the square root of 16 times the square root of 15. But we know that the square root of 16 is 4. And we can't do anything with the square root of 15, so we're going to leave that guy. So that was a great choice. And then plus or minus, and then x. Excellent. Great job. All right. So let's go ahead and we'll stop there for today. We covered a lot of ground today. We did good. All right. So if you don't have any questions, I'm going to go ahead and shut down the recording. Thank you guys for stopping by. And we'll see you next time.